At the end of this course, we're going to have a whole chapter devoted to quadratic equations. We're going to learn how to solve them by a few different methods. We're going to learn how to graph them, but typically we introduce quadratic equations at the end of our unit on factoring because the first method that you learn for solving quadratic equations is to solve by factoring. So we're going to go ahead and start our journey into quadratics. Take everything you learn here and hold on to it because, like I said, it will come back again at the end of this course. Okay? So just a quick reminder, a quadratic trinomial is a trinomial of the form ax squared plus bx plus c, such that a is not 0. What makes a quadratic quadratic is the fact that you have that exponent of 2 on your variable. So quadratic trinomials are considered second-degree polynomials because they have that exponent of 2, and it's the highest exponent on a variable. Now, you do need to note something. We are getting ready to talk about an equation. Polynomials by themselves are different from polynomial equations. A polynomial is like a single expression all alone, whereas a polynomial equation is a polynomial that's equal to a constant or equal to some other polynomial. So we're going to bring that equal sign back into the mix. And we know from way back in chapter 2 that when you have that equal sign, that allows you to solve. It allows you to find the value for the missing variable or find the value for the variable. Okay? So our first topic is just the standard form of a quadratic equation. So what is a quadratic equation and what do we call standard form? Okay? So a quadratic equation is an equation that can be written in standard form as ax squared plus bx plus c equals 0. So I do want you to understand that when we talk about a quadratic equation and we talk about standard form, you have the quadratic trinomial equal to 0. So sometimes you have to manipulate your polynomial or your trinomial or your equation in this case in such a way that it's equal to 0. So you have to sometimes move things around a bit, okay? What you need to know is that a, b, and c are real numbers. So they could be fractions, decimals, integers. The only condition, again, is a cannot equal 0. If a is equal, the squared term just becomes 0, and then it's no longer a quadratic. It's a linear equation at that point, okay? So make sure you understand that standard form, you want your x squared term, your linear term, your constant term equal to 0. And when it comes to solving, it's always easiest if you make sure the a squared term is positive. So it's easiest to solve if you keep ax squared positive. So as you move things around, move them so that the squared term remains positive or becomes positive, okay? Now, a quadratic equation is called a second degree polynomial equation, and it does have 2 solutions, so that's going to be a new thing. And we'll investigate that a lot more when we get into chapter 9. When we get into that chapter on quadratics, we're going to talk about the graph of a quadratic, and really what we're doing is we're technically finding x-intercepts. So when we talk about standard form of a quadratic equation, we set it equal to 0 because really what we're secretly doing is we're finding our x-intercepts. Ordinarily, we would have looked at something like y equals ax squared plus bx plus c. But recall, to find x-intercepts, we let y equal 0. So to put this in standard form where we can solve it, we just let that y equal 0. So that's why we're setting this equal to 0, okay? So there's a rhyme and a reason for this. It'll kind of come full circle when you get down into the last chapter of this book, okay? So the first thing we want to do is put each of these quadratic equations in standard form. So we want to set this equal to 0. And again, when it comes to solving, it's always easiest if you set it equal to 0 such that the squared term stays positive. It just makes it a little easier to work with. Okay, so I've got x squared plus 1 equals 2x. Well, to put this in standard form, I need to set it equal to 0. And my x squared term is already positive, so it's going to be easiest if I just move the 2x. Well, 2x is positive. To move it to the other side of the equation, I just need to subtract it from both sides. So I'm going to get x squared. I'm going to go ahead and write the negative 2x. There's nothing to combine it with on the left, so I'm just going to write it by itself, so minus 2x. Plus 1. And then on the right-hand side of this equation, 2x minus 2x is really just 0. So this right here is standard form. And it is set up to where when we solve, our y is technically 0. So we're really just finding our x-intercept. So we're looking where this graph would cross the x-axis. That's what's really happening when you're solving. All right. Part B. Now, when I tell you that it's easiest to solve when ax squared is positive, I really mean it's easiest to solve if you keep the square term positive. So in a situation like this, it would be really tempting to move the x squared to the right because you only have to do one step. But then x squared becomes negative, which is fine, but it's just easier if it's positive, especially when you're solving by factoring. When you're solving by factoring, the x squared term has to be positive. So let's go ahead and move the two terms on the left to the right. So I need to subtract 10 from both sides, and I need to add 3x to both sides. So on the left-hand side, we'll go ahead and start there. We've got our positive x squared term. We now have a plus 3x. There's nothing to combine it with, so we just write that plus 3x. We also have a minus 10. There's nothing to combine that minus 10 with, so I just rewrite minus 10. And then notice on the right, well, 10 minus 10 is 0. Negative 3x plus 3x is 0. So my right-hand side really does simplify to 0. And now I've got the standard form version of this equation. And remember, it's easiest if you keep ax squared positive. When you're factoring, when you're solving by factoring, what we're going to talk about in this particular worksheet, you must keep the ax squared term positive.